Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about a lot of things. So, we're going to talk about how to refactor your player controller into a state machine, and we're going to talk about all of the benefits and some of the drawbacks of doing that. We're also going to refactor our audio system, and we're going to make it way more interesting and way easier to use. And finally, we are going to adjust our enemy so that he can now detect us through walls, and we can set up a buffer between our walls so our steps sound more muffled if we're behind something. So that's what I have in store for you guys today. So let's go ahead and get started. So first, we have to refactor our player character. So what we're going to do is if we come up to the top here, we're going to build this out as a state machine. And when you build a state machine, is first you have to think about the states that you need. In our case, we're going to have 6 states, and we're going to house all of these in an enum. So first we'll type enum states, and we'll kind of plan out our states here. Now our first state is going to be walking. Our second state is going to be sneaking. Our next state will be crouching. Next will be in air. Then we'll have standing, and then we'll have jumping. Okay, and each one of these states has something extremely important about them, okay? So the first one is walking. That's when you're standing up and you're walking. Sneaking is when you're crouched and you're walking, right? You're moving. Crouching is when you're just crouched and not moving. In air is when your character's in the air, most likely falling. Standing is when your character is not moving but standing, and jumping is when your character does the jump action. So that's basically how we're going to break this out. Now, when we want to actually handle our states, we need some way to house that data. So we'll say var current state equals states dot standing. And that should allow us to basically set up our state machine. Now, unlike most state machines, we're not going to have a switch in here. We're mainly just going to use it as a way to switch in between things and check for some data and make things a little bit easier for us to use, if that makes sense. So what we can do is we can head down here, down towards the bottom, and let's create a function. I figure whenever I do refactoring and whenever I start actually building things out, I like to just start by creating functions and pulling stuff out. So for instance, the first thing that we can pull out is we definitely can pull out our surface system, right? So we can just say func get surface like that. And we can say that this is going to return a surface object like that. And then we can basically just scroll up here and grab this whole section of our code. So I believe we're pulling our space state, our surface result right here. And then we're instantiating a surface. So we could basically just grab all of this. We can scroll down here and we could just paste this in. And then since we're returning a surface, we can just type return surface. And then what we can do is we can come up here and just say var surface is equal to get surface, and there we go. And that'll basically handle all of our code down here. Now we are going to need to do some refactoring once we change up our sound system a bit, because that'll be the second half of this tutorial. So we'll come back into here probably and refactor a tiny bit more, but that will work. Now, once we've pulled this out, next, I usually like to get my inputs, right? Because I want to know what kind of inputs I have. So let's create a function for that. So func get input. And we know this is going to return a vector3, so vector3. And what we can do is we basically can just run through and grab our input code. So I know it's littered throughout this, so we'll need to do a lot of pulling to get it. But what we need to pull is our var directions. So these guys right here. So we'll copy that. We'll paste these guys in here. And then we need to basically handle our flashlight. So let's head up here and find our flashlight code. I believe we have a section in here where we're pulling our flashlight right here. So we'll just grab this guy, come down here and paste it in. And we might want to actually put this into its own function. So we'll just kind of grab this guy and say handle flashlight like that. And then func handle flashlight. There. And we need to fix this real quick. There we go. And we can come in here and we need to figure out our next section, which basically is probably going to be our crouch code. So if we look for our crouch code in here, and I'm not liking what I'm seeing here, so let's scroll down here and just kind of code this part out. So we are going to handle our input as almost like our state machine switcher. So sometimes it's easier just to code it. So if direction does not equal vector3 dot 0. So if we haven't moved at all, and if input dot is action pressed crouch, then we can set our current state equal to state dot sneaking. Else we can set our current state equal to states dot walking. Now, what this is doing is it's literally just checking if we. Now, what this is checking is if we actually have our state set for movement. So basically, if we are moving, so if we are going anywhere, if we are crouched, then our state is crouched and sneaking. If not, then we know that we are moving. So therefore, we have to be walking. Right. And then if we're not moving, so else if we are not moving, then we need to check if we're crouched, much like up here, right? Because we're basically doing the exact same thing down here, just slightly different. We're saying states.crouch, crouching, and states.standing, okay? And I'm basically using this entire input section as a state machine, okay? And then we'll check our jumping stuff. So if input dot is action just pressed, quote, and I think we have a UI button for this, but I think I'm going to just go with jumping or jump. And I'm going to scroll up here and go to my project settings and go into my input map and just added a new action called jump. And I'll add that and I'll click on this. I'll click on filter for input and I'll hit the space bar. That way we have a human readable thing. Because if I just do UI input, it just doesn't sell as well and it doesn't sound as good. So it's just better off to go that way. And is on floor, then we know that our current state is jumping. So current state is equal to states dot jumping. At least I think that's what we called it. Yes, that's what we called it. Cool. But what happens if we are not on the floor? Okay. That means that we must be in the air, right? If not is on floor, then we know that we are in the air. And what we can do is we can just return our direction. And there we go. Now, I know that this seems kind of crazy, but what this is going to do is it's going to simplify a lot of our code up here. You don't see it quite yet because unfortunately, I can't really refactor the code as I'm doing this because there's a lot here that I just needed to manually code. But the whole goal of this is to basically allow us to have a nice state machine handler here that we can use our inputs for, if that makes sense. But once we have that, what we can do is we can handle our movement next. So we'll put in another function. So func handle movement. I'm going to pass in a direction. That's going to be a vector3. and our delta time. Float, and this whole function's job is to handle all of our movement code. So first we'll need to get our speed. So var speed, if you remember before. So we had our speed, if I remember correctly. Let me scroll up real quick. It was capital speed, not lowercase speed. So capital speed. And then we can start actually using our state machine. So we can check if our current state is equal to states.sneaking. And if it happens to be sneaking, then we can just say speed is equal to crouched speed. And then we can also check if our current state is equal to states.jumping. And if it is, then we can just set our velocity dot y equal to jump velocity. You guys can see how powerful this is because there is no way that we could ever be in sneaking state and in jumping state at the same time. So if you're jumping, you can't be sneaking, and if you're sneaking, you can't be jumping. So it makes it so that our code is very segmented so that things just work. They don't break down as easily. Now, we do have some code up here where we're doing our direction code. We can actually set that up. So grab this bit of code here and paste it, and then just say else, and come up here and grab this bit of code, copy it, and paste it. And there we go. And what this is doing is it's basically just grabbing our movement code out of our code base here, and it's reducing our complexity. And again, that's the name of the game. That's what we're trying to do here. And actually, I think I grabbed the same one twice because I am dumb. So there we go. Yep, there we go. And that's kind of the name of the game here, is that we're going to try to normalize our code and make things simpler to read. Now, we do need to do our falling code, and we have some of that falling code up here where we are doing this section here. So we'll just grab this little bit up here and paste it down here. There we go. And then we just need to move and slide. And we have our movement code basically done. It's that simple. Now, like I said, you might be wondering to yourself, okay, so is abstracting all of this code a good idea? Yes. And the reason why is because when you find a problem, it is going to be in one of these functions here. And if each function serves a purpose, then we can go straight to that function if we know something's broken. If I'm pulling back the wrong surface, I know I can look at my get surface code. If I have a problem with my flashlight, I know it's in my handle flashlight. If something's wrong with my state machine, it's probably an input get input. And if something's wrong with movement, it's in my movement code. And that's kind of the going thing that I'm trying to do, is I want to make it simple for us. Now, in the spirit of making it simple, we should also do our sound. So let's come up here and type func handle sound, and let's pass in a surface object. We'll make that type surface. Now, this whole section here is going to be different because we're going to need to refactor our entire surface system. So let's put a pin in this real quick, and we will handle that in a second. So let's do our last section, which is our animation. So we have sound, we have movement, we have input, we have flashlight, we have surfaces. Now we just need to handle animations. So func handle animation, and we'll need to handle all of our animations. Now, we really only have one animation, and that is our crouch animation, right? And technically our flashlight animation. But I'm going to leave that to the handle flashlight part. I think that that's fine. So what we can do is we can basically just grab our crouch code right here where we're doing our physics raycast, and we can basically just run that code, right? So we'll just grab all of this guy, copy it, come down here, and basically paste it. Now, we are going to need a space state, so we can just grab var space underscore state is equal to get world 3D dot direct space state, and that will return our space state, and that will basically solve that little problem. Now we do have a identifier space state is not declared. Oh, that's just up here. That's fine because most of this is going to get deleted. So let's just basically mute all of this. Let's kill it all for now. We'll just hit Control K and that will comment this out. And that should work. Now, we do have a name direct space state is not a function, but a physics space state 3D. So we don't need that. There we go. And we do need to make some adjustments here. We don't want to check if our input is pressed for crouch, right? We want to just check if our state is crouching or sneaking, right? So current state is equal to states dot crouching, or current state is equal to states dot sneaking. And then the rest of this can pretty much play out like we'd expect, right? And actually, I think I put a period on my states. Oh, states dot. I thought I wrote this, but crouching. There we go. And this can all play out like it was, where it literally just checks for if we're crouched. And if we are, then we'll play crouched. We'll say crouched is true. That's fine. And then we can also check here, else if crouched, our intersect ray, if crouching result is equal to 0, then we can play our uncrouch animation. But one of the things that we'll need to keep track of is if we are crouched and we let off the button, our state machine is going to say, oh, well, this person is crouched, right? They must be. But unfortunately, there's some funkiness here that we're going to have to be cautious of. So we need to actually set our state machine to sneaking instead of crouching. Because when we let off of our control input here, what's going to happen is it's going to check if we're crouched. It's going to say, oh, yeah, you're crouched. So therefore, we can raycast. And then what happens if there's something above us? Well, then the game thinks we're uncrouched, or the state machine thinks we're uncrouched, but we're not, right? So we just need to set that. So we'll just say else current state is equal to states dot sneaking, like that. And that'll basically help even that out a little bit. And I am used to C# coding, so forgive me. There we go. I just got done recording my C# tutorial earlier today, so it got me a little confused. Now, once we have this, everything should basically slot into place. So now we can just come up here and just say, all right, we need to make sure that we have some of our non-standard state stuff in here. So for instance, like was in air, which we'll set to not is on floor. And we'll need to get our input. So var velocity is equal to get input, like that. And then we'll need to get our light level. So light level is equal to, if I remember correctly, we had code for this. Light level is equal to get node light detect, because we're going to need to bring this up because, you know, we have all this commented out. And then we are going to need to just run our functions like we normally would. So we need to handle our sound, right? So handle sound, and that requires a surface. So we just can grab our surface code here because it's the only place that our surface matters is when we handle our sound, right? And then we need to handle our animation, and then we need to handle our movement. And our direction is our velocity, and our delta is our delta. And then we can basically just get rid of all of this code here, and we've successfully simplified our code base quite a bit. And I know it doesn't seem like we did, because you might look at it and go, well, I mean, now everything's kind of out in their own functions. But believe me when I say, when you are debugging, this is night and day between 15 minutes of debugging and 5 hours of debugging. So it can really change your life. So next, we will handle our handle sound, because we're going to need to refactor our entire sound system, because we're going to move over to using resources. This is something that came up after I actually recorded this tutorial, and I was like, "Oh man, this would be amazing to use." So we're going to go ahead and migrate over there. Now, how we're going to handle our sound system is we are going to use what's called resources. And resources are basically bundles of object data that we can use on our objects. So basically, we're going to take our sounds and put them into a resource, which is basically a Godot object. And then we're going to assign those to surfaces instead of how we're doing it. So if you look at our audio manager here, you see how we have all this stuff, right? We're building our surfaces in code. But instead, what we can do is we can basically just build resources and not need to do all this building here inside of code. So if we head over to our surface and instead of having extends node, we could just say extends resource like that. And then we can hit at export var sound value. Then we can come in here and paste these guys in here, hit Control S, and this is now a resource object. But what does that mean? Well, here's where the cool part comes in. If we come down to our sounds, we right click on it and go to new resource, you will see we have a create new resource. Now, create new resource, a resource in Godot is, like I said, anything. So it could be an audio file, it could be a bitmap, it could be a bone map, it could be objects, it could be anything. In our case, we're building a custom resource, and a custom resource means that we need to use the resource type. So we'll pick resource and hit create. And then we'll type wood.tres. If we click on wood.tres, you'll see there's not much going on here. But if we come down here and we grab our surface resource object here and we drag it over here, suddenly we have all of our stuff right here. And then we can come in here and grab our wood walk sound, our wood sneak sound, our jump land sound, and then we can set up our sound values. If I remember correctly, this is 5 and this is 10. And that basically solves it. Now, we can also take this and duplicate it and type concrete.tres. We can double click on that, do the same thing, drag in our surface, make this a 6, make this a 12, and then drag in our footsteps on concrete, our footsteps on concrete, and our jump land sound. And that literally solves this for us. Now, we do need some way to get back that object, but you remember how we're raycasting to our surface, right? So if we head over to our test scene and we click on our wood object here, we could do one of two things, and it's up to you and it's dealer's choice. You could come down here and you could add in a metadata and pull back a resource. I believe it's right here if you want to, if you don't want to create a special script for it. But in my case, I'm just going to go ahead and create a script. I think it'll be easier that way. So we'll right click, add in a new script, and let's just add in a surface object script like that. And then we'll double click on our surface object, and we don't need any of this, at least not for right now. So we'll just do that. And then we'll just say var surface resource, and we will make that type surface, and we will export that out. So we'll hit at export. Hey, Editor Mitch here. Make sure we make this a class, so class name, and we'll make it a class name of surface object. That way we have some type safety here and it makes things a little bit easier. But with that being said, let's get back to the video. And now if we just click on our wood and we put surface object on our wood and our concrete, you can see we have a surface resource. And then we can just drag this in and say, this is now wood and this is now concrete. And that just simplifies absolutely everything. Now we can basically just come in and get rid of our audio manager. We don't need it anymore, so we can just get rid of that guy. So if we come in here and delete our audio manager, and then we can come up here to our project settings and go to our auto load and get rid of our global audio manager because we don't need that anymore. And we can come into our character where our global audio manager was being referenced, and all that got removed, if you remember. And we can basically just call our code like normal. Now, you'll see that I am passing in a surface, and that's perfect because that's exactly what we want. And now we can basically just build out our sound system. and it'll be way better than it was before. So first, we need to actually set our noise value. If you remember, we're setting it up here. So I guess technically we don't need to set it there, but I think we'll just put this guy down here. I think that would be better. Organized purpose, right? So it's always good to have everything organized when you're doing your code. So why would you put your noise value not in the sound section, right? So you should always do that. And first, we can actually have a bit of code here to do our walking sound. So if current state is equal to states.walking, and if you remember correctly, when we're doing our sound stuff, we need to make sure that our audio is not playing. So not, and if I remember correctly, the variable does not exist. So we need to actually create a global reference to this. So let's come up here and create a global reference to our audio sounds. So var foot audio player $equals $ foot steps. And then we can basically do the same thing. Var jump audio player $equals $ jump. There we go. And then we can basically just say foot audio player dot playing, like that. And I almost forgot, just in case, at on ready, then we can do that. Because if we do it any other way, it's going to break on us. So we're going to want to do that real quick. And then we can come in here and play our sounds. So foot audio player dot stream is equal to surface dot surface. And actually, we're pulling back a surface. Let me see. Hold on one moment. Let's take a look at something real quick. Okay, so we are going to have some bugs here. Because now that I'm thinking about it, because we have a surface, and this should be a surface object. And we'll make this a type surface object. And we also have a problem down here. So let's copy this, paste it on these guys, because we made a change on our surface object. So of course it's going to get upset with us. And what we can do is, if I drag this guy over a bit, give us some more space here, is instead of just doing a global audio manager sound dict concrete, what we can do is on ready, we will build out a surface object, and we'll just kind of put one in temporarily. So we'll just put var init surface object, and we'll make that of type surface object. And then we'll just come down here and make this an init surface object. That'll solve that problem. Then when we come down here, we're checking to see if we have a meta of that surface type. And we're checking to see, we're casting this as a node 3D. And instead of checking for meta here, we can just check if it is a surface object instead. We need to capitalize that S right there. So we'll say if this is a surface object, and we don't need to actually check for this. Honestly, I don't think we need to check for this at all. We can really just pull this guy, put this guy in, grab this guy, kill it, and I think that will work. So if our collider is the surface object, then we're good. And then we know our surface is our surface result.collider right here. So we can just grab this guy, boop, and put that in like that. And then we can return that surface object. And I think that will work. And then if we come up to our sound, we have our foot audio stream surface dot surface resource dot, and then we can just put in our sounds. So we can just say walk stream dot wave. And this is kind of the nice thing about type safety, right? Is that you get that nice auto completion. It really helps out. And then we can just say foot audio player dot play like that. And then we can set our noise value. Surface dot surface resource dot sound value right here. And then once we have that, then we can do our sneaking state. So we can basically just copy this guy. Actually, really, we could just copy all of this. So just copy, paste like that. And then we can just say walk stream wave dot sneak stream wave, play it, sound value divided by, I think we did 3 last time, so we'll do 3 again. And next, we can basically just do our landing sound. So if current state is equal to states dot in air and was in air, like that, then we know we can play our jump sound. So we can just say jump audio player dot stream is equal to surface dot surface resource dot jump land, and then we can play it, jump audio stream player dot play, and then we can set our noise value. You can see it's very much the same thing across the board. And I know you might be thinking we could abstract this out to a function, and you are correct. If we wanted to, we could be fancy and abstract this out to a function, and we might do that in a second. Don't tempt me, because I do like to refactor some code here. Oh, what did I do for this guy? Sound land value. There we go. And then we need to do our stopping sound, right? So when we stop moving, we need to actually stop our playing of sound. But the cool thing about this is we have 2 states that we need to respect, right? So we have our standing state, so state dot standing, or current state is equal to states dot crouching. And then if all of that's good, then if foot audio player dot playing, then foot audio player dot stop. And that's pretty much it. So now we can just handle our movement, handle our sound, handle our animation, and that should do it. So now, like I said, the nice thing about this is we've really simplified our code base, not just on our player side, but on our sound side as well. And we're going to do a little bit of changes to our enemy code as well to make it a little bit more reactive and a little bit more dynamic as well while we're here, because this is supposed to just kind of get us up to a decent system here. So hopefully once this is done, we'll be cooking with some gas. So now if we hit play and I turn off my background music that I like to listen to while I'm recording, and I hit the unmute button and I hit play, let's see what happens. Well, we have a crash. Invalid index surface resource on base nil. That is my fault because I forgot to set up our init surface object. And I knew I forgot something, and unfortunately it was that. So what we have to do is we have to build a surface object. So we'll say init surface object is equal to surface object dot new, and then we could just come in here and say init surface object dot surface resources is equal to, and we can load our default resources. So we actually would need to load our resources. So resource loader dot load, and we can load our actual resource here. So we can pull back our wood.tres, and there we go. We have an initial resource. So if we refresh, you'll hear we made our sound. Cool. We can walk. Awesome. We can't crouch. That's not a good sign. Let's see what's going on here. Well, that's unfortunate. We can jump, we can move. So cool there. We can use our flashlight. It's a little harder to see when it's during the day, but you can see it is changing. So awesome. So we have probably about 90% of our code working, but for some reason our crouch code is straight up broken. So let's look at our handle animation. My guess is it's probably somewhere in there because we didn't really spend a lot of time in there. So let's take a look at it real quick. So our current state is doing that. We're doing a ray cast. That's fine. If our current state is equal to crouching or sneaking, we might want to debug our current state, but we can go from there if we can't figure it out in a few seconds. So this, else, crouched, yep. Result, intersect ray, firing off a ray, avoiding myself. I really should organize this. Can I organize this like this, or is Godot going to get mad? There. That's just a little bit easier for me to read it. Let me see. So if crouched result.size is equal to 0, then play my uncrouch. Current state is sneaking. That's fine. Well, it could be a state machine issue. So let's do this. Let us debug our current state. So we will just come up here. And after we do our handle input here, we're just going to say print current state. And let's see what that does. Well, it's not exactly printing out what I want, but it's printing out 0, 3, 4, 2. Getting a 2 real quick, but it's only for a split second, but it's mostly 4. So 0, 1, 2, 3, 4. And I did for a brief second get, I think, a 3. Let me check my input. I have a feeling that that's what it is. So let me see. Get input. Is action just pressed? Crouch. Oh, I know what's going on. Is action just pressed, not is action pressed crouched? That is our reason why it's broken. How much you want to bet? So let's try that. And there we go. Awesome. So now you can see our states are actually respected. We're crouched. We apparently can uncrouch, or maybe not. Let me see. Yeah, that seems to work pretty well. His detection code is good-ish. Cool. Yeah. Yeah, that works. Okay. Cool. Awesome. So, what did we cover so far? Well, first, we covered how to switch our stuff over to a state machine and why it's important, right? And I'm not done with the tutorial. I just want to recap this. We segmented all of our code, right? We set up our stuff so that we have a section that can handle all of our animations. We built a section that can handle all of our sounds and our movement, handle our input, our flashlight, and our surface. Now, if this was the old code, right, would we have found that bug that quickly? I'd like to think that it would have been a lot longer, but it was super simple. If it's not in the animation section, right? Because I thought maybe the animation was broken, right? Or something like that. Well, no. So then it must have been in the input, right? Because that's the only two places that that code can be. So by segmenting our code, it's made debugging so much simpler. And that is the reason why I wanted to switch over to this system. Now, one of the other things that I got pinged about was, hey, you should not have two crouch and uncrouch animations. And I kind of agree. So instead, what we'll do is we'll just say animation player dot play underscore backwards, and we'll just grab our crouch animation because we're not going to make it different anyway. So I think that will be okay. And it will have the added benefit of if you spam it, it doesn't affect your character. Something that I was told is that if you spam it, it'll break. So that was going to be one way to mitigate that. So perfect. And now we're on the last section of the video. And at this point, we're probably like an hour into the tutorial. So I'm sorry. I know that I tend to talk a lot when I do tutorials. But what I wanted to cover was one last thing, and that was making our enemy system a little bit smarter. Now, if we head over to our enemy code and we take a look at it, and we scroll down here, there is a section in the code where we are checking right here for the player. And something that I thought of yesterday about this is we really should abstract this code out to making it so that the enemy can hear you through walls. And I know that your initial thought is, well, I don't want him to hear me through the wall. But in reality, you can hear people through walls if they make enough noise. So we should make it so that it works like that, right? So what we can do to do this is we can pull this guy out to here. And if I shift tab these guys back, and we don't have our result.collider, right? So we need to get a reference to our player. So if we just scroll up to the top and we get a reference to our player, which actually it looks like we already have a reference to our player. So my fault. We could just come down here and we can go ahead and just do it. So what we can do is we can just check if our player is crouched and our results of player like this and our player on this result.collider and this one. Basically, we're just going to replace them all with player like this. And what we'll do is I'm going to hit enter on these guys to give us a lot more space because we're going to need it. Oh, actually, I guess you can't. Well, that's good to know. So we can actually set up a way to basically handle if the user is behind something. So what we'll do is we'll come up here and we will do our raycast here, and then we can just add in a Boolean here that just says is player behind wall, and we'll make that a type Boolean. And then we can just come here and say, okay, if our result is in group player, then we know that we hit our player. So player is player behind wall is equal to true. And we can come down here and just say if is player behind wall. If they are, then our player noise value is equal to player.noise value divided by something like 2 or maybe 3, right? Or we could minus it by 10, or we could do whatever it is that we want to do here. But basically, that will make it so that if we're behind an object or we're behind a wall, the sound's not going to carry as hard through the wall. So if I do a jump off of something and I'm in the other room, instead of my volume being something like on my concrete here of 12, it'll just be 6. And then we'll take 6 divided by the distance I am from the enemy. And that will give us like a nice low value so that the enemy probably won't even hear us. So that's kind of what I figured would make this a lot more dynamic. So now if we're behind an object, so if I hit Alt F4 real quick and I go to our tutorial scene here and I drag this guy in between us right here, and I hit play, you'll see that he heard us from behind the wall because we made enough noise. Now I didn't rebake the nav mesh, so that's a problem. So let me rebake that real quick. And now if I come over here and I jump, you'll see he's going to come over here and he's going to investigate it because I made enough noise for him to hunt after me. And you'll see he's waiting and then he's going like that. Oh, and I'm too close for comfort for him. Oh, he's very aggressive. So I'm wondering if maybe if I'm crouched, how much noise do I actually generate? So let's take a look at our player noise code and let's see what's going on. So we'll head down here to our sound and let's take a look at it. So first things first, if we are walking and our foot audio is not playing, then our sound value is getting set. And that's probably where our problem is. First of all, we're setting it as walking, not sneaking. So states dot sneaking, right? Because we're sneaking. And we would want to pull this guy out like this and pull this guy out like this and then say if like that, and then we can do this. I think that makes more sense because then we're actually sending out our sound every single frame instead of sending out our sound whenever we feel like it. So I think that works. And then we could do the same thing up here. So basically just grab this guy, Control X, enter, enter, Control V, change this to an if, do that, grab this guy, Control X, paste it, and then put this guy like that. And then we can look at this one. I'm curious if this is going to have a problem. Let's see. So you'll see 5, 6, 2, 5, 6, 2. Okay, I think I figured out what was going on. So we are setting our current state to chasing here, and we really should set it to hunting. And that will make him a lot less aggressive because originally we had this as chasing as a way to demonstrate the different states. But since we don't need that anymore because we have a whole sound system, we don't have to worry about that. So if we hit play, now he'll just hunt after us, even if we make lots of noise until he sees us, which in this case he saw us. So now he's in chase state. But as soon as he goes back to his stuff and we walk around, hopefully, let's get him off a chase state. Let me see. Well, he's still in chase state. So let me see. So somehow he saw the player and went to chase state. So we have 2 matches here for chase state. Okay, and it's just these 2. Okay, so that's the only 2 ways that you can ever get into chase state is if he sees you. So he's hunting. Now he's chasing. Let me see the code here. So let's hit pause. Whoops. Well, I didn't mean to refresh, so I guess we'll cause chase state again. So he's going to come out our way. He's hunting. Now he's chasing. So now, why is he chasing player? Did he actually see the player? Saw a player chasing player. So yeah, I mean, it looks like he did see the player. Players in close earshot, chasing player, chasing, saw player. So I guess our close sight cone might be a little bit on the large side. Let me check to see how big this guy is. Is it too big? I mean, it's not super large. It's probably just the map size, but we might want to look at this as something. We might want to dull his senses a little bit, maybe reduce or increase his light detection threshold, right? But that's something that we can look at later. But I think code-wise, I think we're good with what we have. So that is kind of what I wanted to talk about. I wanted to talk about resources and why they are important. I wanted to talk about how state machines work and how they simplify your code. And I wanted to talk about how we can abstract our code and make it way easier to debug our stuff. And finally, I really wanted to kind of make this into a good system. And I think we're finally at the point where we're good enough that we can start actually designing levels and start making this stuff pretty and interesting. And then we can actually start doing some level-based coding. So things like, small puzzles and stuff like that. If you guys have any ideas, please throw them in the comments below because I would love to actually, build any puzzles you guys want or something that you'd like to see. I think it would be fun. But with that being said, that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.